When we think about space exploration, we usually picture the massive rockets or the incredible robots exploring new worlds. But what if I told you one of the biggest, most difficult challenges is something you can't even see? It's this constant, silent battle against the brutal temperatures of the void. So, let's get into it.
You've probably seen this, right? This is Ingenuity, the little helicopter that made history on Mars. But here's the absolutely wild part. Every single night, almost half of its battery power, the very energy it needed to fly, was spent doing something else entirely.
So what could possibly be more important than flying for a helicopter that's all the way on another planet?
In a word, staying warm. That's it. A constant invisible fight for its life just to survive the freezing cold of a Martian night.
Because on Mars, temperatures can absolutely plummet to minus 90 degrees Celsius. Without heaters running all night, Ingenuity's delicate electronics would have just frozen solid and failed long before it ever got off the ground. That power wasn't for flight, it was for pure survival.
And if you think that's cold, just wait until you see what the moon has in store. It's a place of even more insane thermal extremes.
This chart shows you just how brutal those temperature swings on the moon really are. See, here on Earth, our atmosphere acts kind of like a blanket, spreading heat around. The moon doesn't have one. It's just completely exposed to the vacuum of space. I mean, just look at this difference. It's staggering. If you're standing in direct sunlight, the ground is hotter than boiling water, over 120 degrees Celsius. But then you take one step into a shadow, and the temperature just nosedives to a mind-numbing minus 190. That is a 300-degree swing.
And this is a huge deal at the lunar South Pole, which is exactly where we're planning on sending astronauts next. The sun is so low on the horizon there that you get this bizarre landscape of areas in permanent sunlight right next to craters in deep freezing shadow. A rover could literally drive from an oven into a deep freezer in a matter of feet.
So, how on earth do you build a machine that can survive that? It's not like you can test it properly here. Well, the answer, it lies in the digital world.
Engineers today rely on this incredibly powerful tool called engineering simulation. They basically create a digital twin, a perfect virtual copy of their spacecraft. And then they can just unleash the brutal physics of the moon on it, testing every possible scenario before a single screw is ever turned.
And the stakes here could not be higher. As the experts at ANSYS put it, if you get the design wrong, that's it. It's over. There are no repair shops on the moon. You have to get it right the very first time.
Okay, so let's see how this all works in practice with one of the most ambitious vehicles ever designed, this pressurized rover that's being developed by JAXA and Toyota.
Now this thing, it's not just a rover. It's basically a mobile home for the moon. They've nicknamed it the Lunar Cruiser, and it's designed to let astronauts live and explore for weeks at a time, over a mission that could last 10 years. This is a total game changer.
But trying to manage its temperature is, well, it's a complete nightmare. Just look at this table. It shows how the heat being generated inside is constantly changing. When it's driving, the motors get really hot. When it's parked and recharging, the power systems are pumping out tons of heat. It's a constantly shifting thermal puzzle.
So to solve this, the cruiser has two main systems. First, there's the active thermal control system. The easiest way to think about this is like your car's cooling system, but on some serious steroids. A fluid loop circulates all through the rover, picking up waste heat from electronics and even the crew, and then it pumps that heat to external radiators to get rid of it into space.
And working right alongside the active system is the passive system. And this is all about insulation. The crew cabin is wrapped in this incredible material called Nikes MLI, which is something like 10 times more effective than the insulation we use on Earth. Seriously, think of it as the most advanced thermos ever built, keeping the scorching heat out during the day and locking the life-saving warmth in during that frigid 14-day lunar night.
So you think, okay, problem solved, right? Well, not quite. The moon has a couple more nasty surprises in store. The challenges go way beyond just hot and cold.
Besides those insane temperatures, what do you think is a rover's absolute worst enemy on the surface of the moon?
The answer is dust. But we're not talking about the kind of dust bunnies you find under your bed. This is lunar regolith. It's finer than sand, sharper than microscopic glass, and it gets into everything. The Apollo astronauts learned this the hard way. This lunar dust clings to surfaces, and if it coats those big radiators, they just stop working well.
They can't reject heat. At the same time, that dark coating of dust makes the rover absorb more heat from the sun. It's this awful 1-2 punch that can lead to catastrophic overheating.
And there's one final tricky complication. As the rover moves through that cratered landscape, shadows from boulders and crater rims are constantly sweeping over it. Every single time a shadow hits, it creates a rapid thermal shock that the entire control system has to manage instantly.
So when it comes right down to it, our ability to explore other worlds doesn't just hinge on powerful rockets. It depends on mastering these invisible forces, the temperature, the radiation, and even the dust. Solving these incredibly complex thermal puzzles is what's going to let us actually live and work on the Moon, on Mars, and wherever we decide to go next.
It really makes you wonder, doesn't it? Beyond just the heat and the cold, what other invisible forces are just waiting for us out there as we keep reaching for the stars?